Hello again, and this is Miss Cowan. We're going to be doing trig functions of rotations today. Yesterday we talked about thinking about angles as rotations, and today we're going to talk a little bit about quadrantal angles and finding the trig ratios of those special right triangles. So as a quick review, this is what your quiz is going to look like. You're supposed to copy and fill in exact values for the chart. You have to know the exact values. No decimals, like square root of 3 over 2. You got to leave the roots in it. Those special angles are ones that you can always use the exact values for. And like I mentioned to you, if you know those, then when you're doing calculations, sometimes things cancel out. Whereas if you round the decimals, you never get things to cleanly cancel. So that's part of the reason why we are doing these. If you notice, 30, 45, 60, those are pretty easy. You should know 1, 2 square root of 3 and 1 square root of 2 for those. But 0, 90, 180, 270, those are called quadrantal angles. And we're going to talk about those today. Let's just do a quick review of the 45, 45 and the 30, 60, 90 right triangles. 45, 45, you know that the two legs are equal. If this is 2, what would the other sides be? Well, I made this one 2 for a reason. And if you remember, to find the missing side, we're going from a hypotenuse to a leg. So we're going to shorter. So we're going to divide, not multiply. And we're going to divide by the square root of 2. You can also use Pythagorean theorem, but if you remember, it's x root 2. So to go from hypotenuse to the leg, we're going to divide 2 by the square root of 2. Don't like leaving a square root on the bottom, so what we're going to do is multiply the top and bottom by square root of 2 to rationalize. So you end up with 2 square roots of 2 over 2, which cancels the 2's out, and you end up with just plain old square root of 2. I'm doing this because, hint, hint, nudge, nudge, wink, wink, you're going to have to find sine, cosine, and tangent, and it's nice if you have the sides being the square root of 2 when you do sine and cosine and so on. Then you don't have to rationalize every time. Now 30, 60, 90, this one's pretty simple. If this is 2, you should know that the short leg is half as long as the hypotenuse. It's easy as 1, 2 square root of 3. So this one's going to be 1, hypotenuse is 2, and this one's square root of 3. So if you have to find sine of 30 is 1/2, cosine of 30, square root of 3 over 2, sine of 60, square root of 3 over 2, and cosine of 60 is 1/2. So those are what I mean by exact values. Let's talk about quadrantal angles. So this is from your pre-printed notes in your packet. What if the terminal side lies on an axis? So if it's exactly on the x-axis or on the y-axis, the terminal side does. Well, what do? Those are called quadrantal angles. The quadrantal angles are 0, 0, 90, 180, 270, and 360, which is the same as 0. Remember from yesterday, we can think of the sine of theta as y over r, cosine as x over r, and tangent as y over x. Also, from a blast from the past, cosecant is the reciprocal of sine. Remember, these always have one co per pair, sine, cosecant. That's going to be r over y. Cosine, secant, one co. So that's r over x, and cotangent is going to be x over y. Just so that you're familiar, don't forget about those reciprocals. And this gives you where the different ones are positive in your quadrants. All right, so let's look at the quadrantal angles. I'm going to show you the reasoning behind it. Hopefully you can follow. If we start with 0 degrees, remember that these are all quadrantals, 0, 90, 180, 270, because they are right on the border of the quadrants. You would have your r, your coordinate on the circle is r comma 0, right? Because it's 0 degrees. So the terminal side and initial side are the same. The radius is the x value, and it doesn't go anywhere vertically. So 0 is the y. So when you do y over r, you'd have 0 over r, which gives you 0. Cosine is going to be adjacent over hypotenuse, or the r over x, or x over r, but x is r. So it would be r over r, which is 1. Tangent is going to be y over r. I'm sorry, y over x, which is going to be, again, x is r, so it's 0 over r. And I know this doesn't make sense too much, but just get these memorized. If you put it in the calculator, sine of 0 is 0, cosine of 0 is 1, and tangent of 0 is 0. Now if you do the same for 90, if you look here, here is my point that's on the circle. X is 0, Y is R, and R is R. So 90 degrees, Y over R is going to be R over R, which is 1. Cosine is going to be 0 over R, which is 0. And tangent is going to be R over 0. Well, whenever you divide by 0, that is undefined. So we'll put undefined. You can't divide by 0. 180 is over here. Here, X is the opposite of R, and Y is 0, and R is still R. So we have 0, -1, and 0 for that one. -1, 0, and undefined. If you look here, it's like tic-tac-toe. If you can do this chart, you go diagonally 3 zeros, diagonally 3 zeros. And then the ones alternate. 1, 1, -1, -1, undefined, undefined. So somehow make a system, memorize that so you know, for example, the sine of 90 is 1 and so on. You're going to have to put those on the chart on the quiz tomorrow. Reference angles. I meant to delete this, but reference angles are the acute angles formed by the terminal side and the x-axis. So when I'm looking at this picture here, this is the original angle, and I draw it between where that angle ends and the x-axis. It always has to draw to the x-axis. Never, never, never to the y-axis. So if I look, if theta is in quadrant 1, theta is less than 90, then the reference angle is just theta. You don't have to do anything to it. If the theta is between 90 and 180, you do have to do something to it. So there's where theta would lie. Terminal side is in quadrant 2. You'd have to get this little angle here. Well, you know all the way around is 180 degrees. So to find what theta is, you're going to do 180 minus theta. So reference angle would be 180 minus theta. Let's say it's in quadrant 3. Theta is between 0 and 270. So here's where the terminal side is. We would take and find this angle that's inside of here to the x-axis. So we'd go upward. That's your reference angle. And to find that, you'd do theta minus 180. And lastly, if it was in the 4th quadrant, so all the way around there, to find what the reference angle is, you'd do 360 minus theta. If you can't do it intuitively, most people can look at it and go, okay, how much to get back to the x-axis, and they can find it that way. Notice we never use 90 and we never use 270 when we're finding the reference angle. It's always either itself, dealing with 180, or dealing with 360. All right, so let's find the reference angle for these guys. So right here is theta equals 115 degrees. That's where the terminal side is. Reference angle is in between here. So it's in quadrant 2. I'd subtract from 180 to get 65. Most of you know that two angles that form a straight line add up to 180. So that's right along those lines. This one right here, you got 225. It goes past 180 a certain amount of degrees. You'd subtract it from 180. You just subtract 180 from 225 to get 45 degrees. So that's your reference angle in there. This is important because when you go to do your trig ratios and you want the exact values, you want to be able to find that little triangle in there and do what's called a reference triangle. Let's say, for instance, they want you to find the reference angle for theta. So on this case, it goes all the way around to 330. So this little thing would be the reference angle. 360 minus 330 would be 30 degrees. Here we're going around this way. And notice it is negative. So you'd think, well, is the reference angle negative? No, it isn't. You just do 180 minus 150 and you get 30 in there. It's always positive. Well, part of your homework or classwork is going to be to find sine, cosine, and tangent of things like 330, where your reference angle is one of those special angles. What you do is you draw a reference triangle. So your first step is to draw a reference triangle. So let's say this is one of our problems. If r equals 2, find sine of 330, cosine of 330, and tangent of 330. First step, draw that reference triangle by dropping a perpendicular to the x-axis. So this forms your little triangle. And you've got the right angle there. This is 2. That's the radius. So right away, you should know this is a 30, 60, 90. Opposite the 30 is a short leg. So 1 goes over here, and square root of 3 goes on the top. To get the point, to get the coordinates, notice I am in the 4th quadrant. So my x is positive. I'd go to the right square root of 3 units, and down 1, so my y coordinate is negative. Then you can form your ratios very easily. So you're going to have, there's your x, there's your y. Y over r is going to be negative 1/2. Cosine of 3/30 is x over r. That's going to be negative or positive square root of 3 over 2. And tangent of 3/30 is going to be y over x. So that's negative 1 over the square root of 3, but when you rationalize it, you get negative square root of 3 over 3. So again, the steps for that are draw a reference triangle. That's drop a perpendicular back to the x-axis. Then you're either going to have a 30, 60, 90 or a 45, 45, and you can find those sides to get the coordinates of your point. Okay, we'll see you tomorrow.